Hello everyone, my name is Jessica Vasquez. I was part of the CTA offensive track that started back in October. The focus of the track was primarily on pen testing and web app security. Throughout the program, I was able to use the various skills and tools I learned from the MAT 20 Pen Test Plus training and apply it to my capstone project. I really wanted to focus on command and control frameworks because it was something I had not worked on. I wanted to push myself and work on something that will help me in my cybersecurity journey. So for this project, I wanted to show you how a threat actor can use openly available tools like Sliver to create malicious payloads and establish persistence on their target host. So with that, let's begin. The primary goal of my project was to simulate a modern command and control attack chain using the Sliver C2 framework. I was able to use Sliver to generate a payload and modify it using Donut and Nim to bypass Windows Defender. I created a malicious HTML page which hosted the malicious file. When the target downloaded and ran the file, a remote session was open in Sliver. With a session active, I uploaded another malicious file and added it to the target's registry. This would allow for persistence because a session would become active after the target restarts, powers up their machine. I'll then discuss the MITRE ATT&CK tactics and techniques used in this attack. Finally, I'll discuss prevention, detection, and response strategies to secure systems against this type of threat. So these are the tools I use for this project. They're all open source tools, are accessible to everyone. So if you're interested in recreating this or want to use some of the tools seen in the demos, you can download them from the web or GitHub. For the virtualization software, I use VirtualBox. I use Kali Linux as my attacker VM and the Windows 10 as the target. I use Sliver for the C2, use them to compile loaders, which I'll explain later in the slides, and Donut to convert the executables to shellcode, and finally use Python as the HTTP server hosting my malicious HTML page. As a note, this was for research purposes only. I don't condone anyone using what they learned today for nefarious purposes. The purpose of this project is to learn how adversaries are using these tools and how to prevent and remediate. So I included this to give you a visual representation of what you're going to see today. So we have the target who is part of a group looking to buy Labubus. If you don't know what a Labubu is, it's a toy that's gotten really expensive and are hard to find. So one day our target is going out for a walk on their lunch break. On the walk, they see a sticker for cheaplabubus.com. Once they're back from their lunch break, they log back into their computer and visit the Cheap Labubu site. They click on the link to download the Labubu app. When they open the app, the NEM loader executes the malicious payload. This establishes a session back to the Sliver C2 server. With the session open, the attacker is able to upload another payload and add it to the target's registry. So once the target logs off for the day, the next morning when they start up their computer, a session will open, allowing access to their host. So what is Sliver? Sliver is an open source command and control framework developed by Bishop Fox in 2020. It was designed for red teamers and pen testers to simulate real-world attacker behavior in a controlled environment, similar to Metasploit and Cobalt Strike. However, advanced persistent threat groups have exploited Sliver due to its remote capabilities, stealth, and adaptability. It can be installed on Mac OS, Windows, and Linux. Sliver offers several communication protocols, including HTTP, HTTPS, DNS, mutual TLS, and WireGuard. It also has built-in evasion features to generate staged and stageless payloads, encrypt communication, and even evade some antivirus solutions by using in-memory execution and randomized strings. So these are some of the commands in Sliver. The Sliver server is a command and control server. You'll need to start this up first before using the Sliver client. The Sliver client is used by operators, which are attackers, to connect to and control implants on the target system. Implants are malicious payloads designed to evade detection. These are similar to Metasploit's payloads. Think of these as reverse shells. These can be deployed on the target system to establish a session. Sessions are real-time network connections to the server client. Lastly, we have beacons. So these are designed to check in periodically. Beacons can be used in interactive mode to start a session. So whenever the beacon checks in, it will execute the commands it has received. Just note there's a time delay with beacons since it's designed to periodically check in. It doesn't have that constant connection like implants do. Therefore, the time it takes for you to send a command over depends on how often the beacon checks in, which also makes it less detectable. For this demonstration, I will only be using implants and not beacons. So the first thing I had to do to start my attack was to generate an implant in Sliver. I generate a Windows payload that used HTTP communication to my attacker IP on port 8080. I specified the operating system for my target host and architecture. The payload was compiled into an exe file with evasion features. I then started the listener on port 8080 using the command http-l. I created the malicious site using HTML. I added the executable that was created in Sliver and used Python to set up the file. I kept it simple. I kept it simple because I wanted it to look like it was redirecting you to another site. However, it doesn't. On the site as well, there's also a message displayed informing you of a new Lubu app. This is how the target is lured into clicking and downloading the malicious file. On the target VM, because it wasn't a closed environment, I had to add my IP and domain to the etc/host file. I didn't want to buy a domain and I didn't want my target VM to have internet connection since I was deploying malicious payloads. So to keep it simple, I added it to the etc/host file. I also used a host-only connection on my attacker VM once I had downloaded all the tools I needed for this project. So here's our first demo. We have the Sliver client. We'll open it up, generate that payload, the executable. Once that's done, we'll add it to the HTML file, serve it up via Python. And as you can see, there's several error messages, file not found, and that was because I had typed in the wrong file name. So this is the correct one. We see that this the GET request for it, meaning that the user downloaded the file. On the Windows VM, you run a quick scan and defender. And see that there are no current threats. We'll go to the Cheapobubu's site. Click on the link to download. You'll see that the download process has started. However, it does stall, and then when we check Defender, we'll see that it's because Defender flagged it as malicious. so it's preventing the file from fully downloading. So how do we bypass Windows Defender? Well, we're going to be using two additional tools, Donut and Nim. Donut can be found in the MITRE ATT&CK website where you can find additional information. Donut is a tool that can be used to generate shellcode. It converts executables like exe or DLL files to bin files. This allows the payload to be executed in memory without touching the disk, bypassing traditional antivirus EDR detection. The shellcode can be injected into legitimate processes and fetched remotely. Nim is a programming language that compiles to C and supports native Windows API calls. It is used as a loader to execute the donut generate bin file, which enhances evasion since it's lesser known than other programming languages. I used code that was posted by Newman Cyber Labs as a starting point and modified it with the help of ChatGPT. First, we have to generate a new payload in Sliver by adding the domain and port, OS, and architecture. Once generated, it outputs the rev1.bin.exe file. Next, we can check if the listener is still active by using the jobs command. Next, we use the git clone command to download the donut git repository, then run it to convert the rev1.bin.exe file to rev1.bin file. Donut does have flags you can use that can help with evasion, like the B3 flag, which bypasses both AMSI and ETW. So what AMSI does is it scans for PowerShell and .NET scripts for malicious content. ETW logs process activity and is often used by EDRs. The Z2 flag compresses the shellcode, and I is input, O is output. So you might notice that some of the examples shown have different names, and that's because a lot of it was trial and error. I posted this one so you can see what it looks like when you use Donut. I downloaded Nim using the curl command. I had to add it to the .zshrc file because my terminal wasn't as readable before. Once it was good to go, I created the Nim loader called lububuapp.nim using nano. So here's a snippet of the code. I use Nim's winm to call native Win API functions like we would in C or C++. This allows for precise memory and process manipulation. In the product download execute line, right here we have the message box. Please keep this window open for 20 minutes to complete installation. This helps keep the target from closing the window, buying time to establish persistence. If the target closes the file, the connection is severed, so it's important for the target to keep the file open. On the next line, so what these lines are doing right here is it downloads the rev1.bin file from the Python HTTP server. Virtual alloc, this allocates memory with execution permissions. Copy men, copy shellcode into the allocated memory. And this last line right here casts the allocated memory to a function pointer and executes the shellcode directly. So this loader evades writing payloads to disk by passing AV EDR because no file is written. Next, I compiled the lim loader to get an executable called labubu_app.exe. So we basically have our nim loader, labubu_app.exe file, and inside of it, the code, we have the URL address where the bin file is stored. So now let's see how this all works. So here we have our rev1.bin file. We'll start up our listener again. Uh, Next, check Python and see that the user downloaded the Labubu app, and see that rev1 that bin file, meaning they ran that executable. And once they do that, we'll see an active session appear right here. So we can now use this session to access the target host. On the Windows machine, we'll go to the cheap Labubu's site. We'll click on the link to download. And this time it fully downloads. We'll go ahead and try and run that executable by opening up the file. And we're met with this message from Smart Screen saying that they can determine whether or not the file is safe to run. We click yes, and then when we open it, we see this little pop-up window telling us to keep the file open for at least 20 minutes. We'll go back into Defender, run a quick scan. And there are no active threats, current threats, meaning we have just bypassed Defender. So now that we are in the target host, we need to establish persistence. We can do this by generating another payload in Sliver. We are going to call this one updater_edge. Once our payload is generated, we can use donut to convert to a bin file. From there, we need another nym_lodo. So for this one, we're not going to include a message box. Instead, it's going to run in the background. We then use nym to generate an exe file named edge updates_v2.exe. Since we have access to the target host via a live session, we can use the use command in Sliver to start our session. From there, we'll use the upload command to upload the nym executable edge updates_v2.exe file. Now we'll use the shell command to start a reverse shell, which makes it easier for us to move around on the target host. So when we upload the file, it's going to be placed in the downloads folder on the target's directory. We need to move this file to a more discrete location, so we're going to move it to the user's appdata/roaming/Microsoft folder. Once that's done, we'll add it to the registry by using the regadd command and labeling it as a WinUpdate. So what this essentially is doing is adding the file to the boot up process. If the target logs out for the day and logs back in the next morning, it's going to trigger the bin file to run and download the bin file from the Python server, thus establishing a live session in Sliver. And this is going to occur every time the target starts up their host. So first we're going to check our active sessions. Okay, we see that the session is still alive. We'll use the use command to go into that session. And you can see that the implant that we generated in Sliver is being used. We can use a who am I to see what users we are, info to get additional information on the target host. And we could use the background to put the session to sleep. However, we want to get back into it, so we'll use sessions again just to grab this ID, right? Use the use command to verify we got the right session. So now that we're in, have the session active, we'll use the upload command to upload our edge updates underscore v2 executable to the target host. We'll use shell to start a reverse shell. You'll see a little asking you if you're an adult, just input yes to start it. Now that we're in the target host using the reverse shell, we're going to move that file over to the app data / roaming / Microsoft folder. Now that's done, we'll use the reg add command to add it to the registry. And it did it successfully. Now we'll use the reg query command just to verify that it was added, and we use the when update as a name for it. And you'll see it right here. So it has been added to the registry. So we'll exit out using the Control D. We'll background that session. Check our Python server. So right now the user has restarted their computer. And as you saw here, let me stop it. So as you can see here, that updater edge.bin file is being downloaded to the target host. So this means that the target has restarted their computer. We'll check back in Sliver and see that a new session has been opened with that implant. We'll check sessions and we can see that our old session is dead. However, that new session is active. And the same ID matches the one we just that just opened up. So now we can use that session to gain access to the target host. On the Windows side, right, we still have our app open. We'll check the downloads folder and see that Edge updates folder is in there. It's been uploaded to the target, and we'll see it disappear in a second. Yep, here it is. And we'll go and verify that that file was moved over to the app data / roaming / Microsoft folder, and it is. So now we're going to shut down the computer, close out of the app. Now that it's restarting, we'll log back in. And we'll open up Defender, run another quick scan, and we'll see that there are no current threats on the host. There it is, meaning we're able to establish persistence and again bypass Defender. So I wanted to show you all how this attack chain can be mapped out using the MITRE ATT&CK framework. This is important because it helps us understand adversary behavior in a consistent and structured way. So we start off with resource development, where I mimic the use of an attacker owned domain by configuring the etc/host file on the target VM. Next was initial access. This was achieved through the fake HTML page and a link click. I believe this would also apply to spear phishing via servers, because attackers have started using fake social media pages to lure their victims in. So in this scenario, the user saw the sticker while walking outside. However, this could have also been seen on like Instagram or Twitter. Next is execution. When the target ran the NIM loader, it triggered the download of the malicious bin file. The user had to click on the link, download, and run the file for the session to start. Next is command and control. Our implants communicated using HTTP. Once they were ran, it started a live session back on the Sliver client. In addition, once in the target host, I was able to upload another file using Ingress tool transfer. For defense evasion, I used Donut and NIM to evade detection. It helped with obfuscating the files. The NIM loader also, more importantly, fetched the Sliver generate binary, the bin file, from a remote server, embedding the malicious payload dynamically rather than storing it on disk, thus avoiding static detection, since the full payload isn't present in the initial executable, which also applies to reflective loading. We named our executable and bin files after legitimate processes like the labubu_app and edge updater, making it hard for the user to determine if the processes are legit. Last, we have persistence. We were able to establish this through the Windows registry modification, enabling for a live session and activate it at boot up. This mapping shows that even in like a small scale project like this, you can simulate complex real world adversary behavior. It also demonstrates the value of MITRE ATT&CK for both red and blue teams in aligning their assessments and detections. Now that I've shown you how the attack chain works, let's shift into defensive mode and talk about how we can stop or respond to an intrusion like this. For prevention, we want to use application controls to block unauthorized executables from running, deploy strong EDR detection endpoint, and response tools that can catch unusual behavior, not just signatures. There are several EDRs out there like Carbon Black, CrowdStrike, and Cortex XDR. I've worked with Cortex XDR and I liked it because it also provides the tactics and techniques from the MITRE ATT&CK framework to incidents, which is pretty neat. You also want to implement email web filtering to block malicious domains or downloads, and conduct user awareness training, especially around social engineering and phishing. For detection, we should alert on new registry key entries under auto-run locations, monitor unusual outbound HTTP or DNS traffic, especially from non-browser processes, use a SIEM or behavior analytics to correlate events that may indicate lateral movement or beaconing, as well as report any suspicious activity. The screenshot below shows a pop-up window after the user restarts their computer. It's an error message for a failed connection attempt. This should be an indicator for the user to report the suspicious activity to their security team. On the Labubu app executable, when I added it to the registry, um, it, it it gave like an indication of suspicious activity and that pop-up window saying that, to keep the window open for 20 minutes. So these are just little things that the user should be suspicious of and report immediately to prevent further access to the host. Now, if the user waits and a breach does occur, you want to isolate the system from the network. kill any active malicious processes and connections, remove persistence mechanisms like registry entries or scheduled tasks, check for lateral movement or other implants, reset the user's password, and in high-risk situations, re-image the machine entirely. These steps align closely with the incident response lifecycle and should be part of any organization's playbook when dealing with C2 or malware-based intrusions. So there were various obstacles that I faced with this capstone project, which ultimately helped me learn from my mistakes. The first was setting up my virtual environment so that my two VMs could communicate. I spent several hours trying to get my Windows machine to direct to the Labubu site, and it wasn't working because I had edited the etc/host file. Instead of saving it, I saved it as a different name, well, the same name as a txt file. So when I was making my revisions, I was doing it in that txt file that I had saved. And once I figured that out, I was able to connect to the Labubu site on the Windows VM. The second challenge I faced was learning how to install Sliver, Donut, and Nim. For some of these installations, I had to modify other files for it to work, like with Nim. Others, like Donut, had issues trying to run it after it was installed. And for Sliver, just learn how to use it overall. There were some instances where I had trouble connecting to the Sliver client, which did not allow me to receive a session when I had run that Labubu executable on the Windows VM. So I was able to overcome this by just doing some research and then restarting the client. Third was debugging the code. It wasn't as simple as just asking ChatGPT. There were several instances where I just wasn't getting a session back once the file was ran. I was getting errors on the target host, and I wasn't able to bypass Defender. Even though I relied heavily on ChatGPT for debugging the code, through further reading and some YouTube videos, I was able to understand at least some of the more important aspects of it. And this is gonna help me in areas as well in the future. Fourth, there was issues with my Kali Linux machine not having enough disk space. I failed to realize that some of these implants I had uh, just taking up a lot of space. So I had to delete some of the files before I could continue generating new implants in Sliver. And since this was an enclosed environment, there were some things I had to do, like add the attacker IP to the etc/host file. Also, when I had my Kali Linux machine off or Python wasn't running and the user restarted the computer, the Windows VM, there would not be a session active in Sliver. Right, so Python must be running at all times for the session to become active because it downloads that bin file. So like on the Windows machines, that's when we see that uh, window pop up with that error saying that a connection failed to occur. I guess, but the biggest takeaways was how powerful and stealthy some of these attacker tools are. Running this end to end helped me just see things from an adversary's point of view, which uh, helps me make me a better defender. I also gained confidence in using frameworks like MITRE ATT&CK to document and explain complex behavior in a clear and structured way. This project demonstrates a realistic adversary emulation scenario using the Sliver C2 framework. We were able to see how an attacker can establish command and control, obfuscate the malicious payload by using tools like Donut and Nim to bypass Windows Defender. Once gaining access to the target host, we established persistence by modifying the Windows registry to run the malicious executable upon startup. We used Donut and Nim to obfuscate and deliver shellcode by bypassing Windows Defender that mapped the attack chain to the MITRE ATT&CK framework, illustrating tactics like initial access, execution, defense, evasion, and persistence, and provide a set of practical remediation and detection strategies to prevent and respond to similar real-world attacks. And finally, talked about the challenges and lessons learned from this capstone project. I hope all of you learned something new and was helpful in understanding how modern attack chains work and how we can use open source tools like Sliver, Donut, and them to emulate these types of attacks. Thank you very much.